Hey everybody, and welcome to Lesson 1 of Unit 1. We're talking about relations and functions today. This is a pretty important concept for us to start understanding now because pretty much the rest of math, you're going to be seeing functions come up. So you want to get used to them. They're not really that bad. So a function is just a relationship where each input has exactly one output. I'm going to show you an example of that in a second. Something else we want to know, that it's written as f of x is how you would say this out loud, f of x, where x is the input. You could also have other function names, right? F happens to be the function name here. You could call it g of x if you wanted to. You could call it h of x. You could have a different input. You could have maybe n's or a's. It doesn't really matter. Okay, but we would read this particular one as f of x. So here we have an example of a function. We have f of x, so some function when we input a value, and this is what the function looks like. This is what's going to happen, right? And anywhere that we see an x in this particular function, we're able to evaluate there, meaning that when we plug in a number, an input, we should be getting some different number out, and exactly the same number every time from this. So this example, right, we have 9x plus 7. If I want to evaluate the number 2, everywhere that I see an x, I'm just going to put in a 2. This is telling me here multiplication, so we have 9 times 2, which is 18, plus 7 gives us 25. We follow all the usual order of operation rules, so we did our multiplication before our addition, right, all that type of stuff. Now, where this becomes a function, right, is that if I plug in 2, again, I'm going to get 25 out. I'm not going to get 31 or negative 16 or some other number. No matter what, if I plug in 2, I will always get 25 out. And that's what makes it a function. So I have for you to try evaluating 10 into this function. Pause the video and resume it when you're ready to check. Alright, let's see. We want to do 9 times 10 plus 7. Take care of the 9 times 10 first, giving us 90, plus 7 gives us 97. So it doesn't matter if I plug in 10, it's always going to give us 97 out for this particular function. If I plug in 2, it will always give us out 25. You plug in different numbers and evaluate, you'll always get a different, you'll always, not necessarily different, but you'll always get a number out, and it will always be that same number as a result for that particular input. Okay, let's look at it in a different way. Let's look at it in set notation form. Okay, when we talk about a function, we usually talk about the input x and your output being f of x. And we can write this in coordinate form, and it matches what we've been doing before with x comma y, where your f of x is your y result. So we relate every f of x result to y, and now we have a system that works for us, right? So if I look through here, determine the relationship is a function. If I plug in an x value, I should be getting out the same y value for that x input, right? So here I plugged in a 3, I got an 8. Plugged in a 4, I got out a 10. Plugged in a 5, I got out a 12. So I plugged in different numbers each time, and I got random numbers. There's nothing wrong with what I'm seeing here. So this is a function. I'm going to put yes for determine if it is. This example will show you why we don't have a function, right? I plug in 9, we get out 4. I plug in 6, we get out 1. I plug in 9 again, I get 5. A different number this time than what I originally got for 9. So because we're getting two different answers for 9, this is not a function. Okay, didn't matter what 6 gave us. The fact that 9 gave us two different answers, that's where the problem lies. Let's check out C. Right, we plugged in A, we get out B. I don't know what these numbers are, but as long as I get B for A later on, we're fine. I plug in 3, I get out 9. I plug in 3, get out 9 again. Plug in 2, I get 5. So it didn't matter, I didn't see A later on. That's fine, it checks out. This checks out. The fact that we plugged in 3 and got the same number both times, this is good. That means this is a function because we're getting the same number out. So yes, This is a function. In our last example, if I plug in 2, I get -1. If I plug in 3, I get -1. Plug in 5, I get -1. Well, it doesn't matter that I'm getting the same result every time. That does not matter. As long as I don't get something different when I plug in each of these individual x inputs. And it doesn't show me that there's a problem here. So as far as I can tell, this is a function. Okay, there are 4 more for you to try over here. Pause the video and resume it when you're ready to check. I won't go into as much detail next time about those solutions. Alright, let's see how you did here. If you plug in 6, you get out 2, and you plug in 6 and then get out 3, that's a problem. Right, 2, 3 gives you 2 different, so we have a non-function here. I plug in 5, 2, and -1. I only plugged them each in once. They gave me different results. All that checks out. That's fine. That's a function. If I plug in 3, I get out 5, and 3 and 5 again. So this is good. PQ, 6, -2, all these look fine. Right? We're not getting different numbers for the same x. Here, -1, 9, -1, 5. That is a problem. So we do not have a function here. These might work, but these two do not. We can also do this in a table of value form. So if we were to draw these out in a table and we would put all of our x's on one side, all of our y's on the other, we would just look across to see if we have any kind of problems arise. Now comes to our next little piece of information called the vertical line test. This is actually a really super simple way of checking. I think everybody's going to get this. It's pretty simple, right? If you draw a vertical line through the graph and it intersects more than once, then the graph is not a function. So I have pictured here a whole bunch of graphs that we're going to look at, and if we draw a straight vertical up and down line anywhere on that graph and it hits more than once, not a function. We're going to keep in mind a couple of things like closed and open. If it's a closed point, right, it's actually hitting there. If it's open, it's kind of passing right through. Okay, so let's look at our first example. We want to determine if this relation is a function. We have this really squiggly, dragon looking like function. I don't know why I think it looks like a dragon, I just do. Anyways, if I draw a vertical line here, it only hits once, so problem not exactly solved yet because I've only checked in one spot. And I could continue to check over here a whole bunch and only hit once. What I'm looking for, though, is if I can hit it more than once with a vertical line. If I were to do that right here, now I'm hitting 1, 2, 3. That becomes a problem, making it not a function. Okay, checking over here, right? I might be able to go straight down here and here, that's all fine, but as soon as I go like this, I'm hitting the function too many times. I can do that as well over here. I'm hitting it too many times. So this is also a no. Finally, if I start drawing vertical lines through here, everything's great. What about here, though? Well, as I mentioned up here, this open circle means I'm going through. So I'm not actually hitting the point right here. It's just showing me roughly where that function would be height-wise. So I'm not hitting twice. I'm only hitting once right here. And we can keep on going, and it happens again. I'm only hitting once right here and passing through. So this is actually, yes, a function. There's one more thing that I didn't show you on here. So I'm going to quickly just draw one off to the side. Okay, let's say this is our xy plane. If we have a function that does something like this, right here, that's a problem. And here's why, right? If we were to draw a vertical line straight through here, how many times is it actually intersecting this piece? It's actually intersecting an infinite number of times between here and here, right? Those points are infinitely small, so it's intersecting continuously from here to here. So if it was bad hitting it twice, it's really bad hitting it infinite number of times. So this particular example would also be a no. Okay, so if you see vertical lines appear or if you see it overlap, those are where your problems are. So I have 3 examples for you to try. You might want to pause the video and draw them out, or you could maybe just do it by tracing your finger. That's up to you. But you can pause and resume when you're ready to check. Alright, these are pretty straightforward, right? If I draw vertical lines, it doesn't matter where I draw. I'm only hitting once, and as long as I only hit once throughout, that makes it a function. Over here, we're doing really good, right? I hit only once up here. We're doing fine. Uh-oh. Here's where we have a problem, right? We hit twice in a row. These are closed, so this is not a function. And then finally, we have over here, once I get to this point right here, I'm only hitting once. And again, only hitting once, so this all passes the vertical line test. We're good here. Alright, we've got only a couple more things left to look at. We actually looked at evaluating functions earlier. You did one at the very beginning of this video, but sometimes we have functions that are going to be evaluated for more than one value, and sometimes we'll evaluate another function inside of a function. So I've given you an example here. F of x equals 5x squared minus 8, and they gave us 3 different things they want us to evaluate. 2, -1, and then 3p. Right? We're going to plug in 3p and see what happens to it. So let's do each of these individually. First we'll do f of 2. Notice how I'm actually writing what I'm evaluating here. We want to make sure we follow PEMDAS or PEMDAS, however you say it. So we need to make sure we do our exponents first. 2 squared would become a 4. 5 times 4 would be 20. 20 minus 8 gives us 12. So we get 12 as a solution. And if we wanted to write it as a coordinate pair, we would write it as 2, 12. Meaning, if I plug in a 2, I should always get a 12 out. Let's try for -1. Again, we'll take care of our exponents first. -1 squared, that's actually just +1. 5 times 1, that's just 5. 5 minus 8 is -3. So if I plug in -1, I'm going to get out -3 every time. Notice again how we're writing our solutions as coordinate pairs. And finally, this one's not going to be pretty, but we're going to do it out. If we do 3p, so anywhere that I saw an x, I have to plug in 3p. 3p squared, well, that 3 squared becomes a 9. So we've got 5 times 9. And then if I square p, I don't know what p is, but it's going to be some number squared. So we have 5 times 9p squared. I can do 5 times 9. That's 45. P squared minus 8. Now I can't go any further with that, right? I can't combine any like terms because these are not like terms. That's it. So our answer, I guess we could write it this way: 3p, comma 45p squared minus 8. I don't see it written that way too often, but hey. Alright, one last problem for you to try out. Very, very similar, so take your time, pause this video, and resume it when you're ready to check. Alright, let's check it out. We had 15 minus 2x squared, and they want us to do 4, -3, and 5y. So let's start with 4. 15 minus 2 times 4 squared. Alright, 4 squared, that's 16. 2 times 16 is 32. And 15 minus 32 is -17. So if we plug in 4, we get negative 17 out. Let's try negative 3. If I square negative 3, that becomes positive 9. 2 times 9 is 18. 15 minus 18 is negative 3. So negative 3, negative 3. And then our final one, 5y. Again, we have to make sure we distribute that to both terms, that square, before we do that multiplication. So 5 squared would be 25. Y squared is just y squared. And then we can multiply 2 and 25 to give us 50. Y squared. So we can't combine any like terms right here. Our final answer, if we write it in coordinate form, would be 5y comma 15 minus 50y squared. Not bad. Got a lot of stuff kind of crammed into that one lesson, but we got it done in only 20 minutes. Not bad. So we'll continue looking at functions a little bit more on the next couple of lessons. Until then, see you later.